All right, continuing on with section 9.3, we're still asking the question, when does a series converge? And with this video, we're talking about a couple ways that if we have a series that we already know if it converges or not, what does that tell us about similar related series? So there are, this is theorem 9.2 from the book, and there's a few, total of 4 statements. And we're just going to be going through a few of these, and then I'll ask you to think about some of them towards the end of it. So theorem 9.2 starts off by saying that if we have 2 separate series that converge and we add them together, that the new series also converges. So this should make sense because if we have, let's say our an is 1 over 2 to the n, and our bn is something like 1 over, let's say, 10 to the n, so something like 0.1, 0.2, 0.01, 0.001, etc., then the sum from n equals 1 to infinity of the sum of these things, well, this is going to be a1 plus b1 plus a2 plus b2 plus a3, etc. Well, because we're just adding a bunch of things together, we can reorder this. And just because there are infinitely many of them doesn't mean that we're not allowed to shuffle them all. So this thing is the same as 1 over 2 plus 1 over 2 squared plus 1 over 2 cubed, etc. And then also plus 1 over 10 plus 1 over 10 squared plus 1 over 10 cubed, etc. So if we already said that this series, the sum of the ANs, and the sum of the BNs, if we already say that these things converge, that's saying that this series and this other series both converge. Therefore, it's a finite number plus a finite number, and this whole thing is also a finite number. Cool. The whole point of this is if we add 2 series that we know converges, we're adding a number plus another number. We're allowed to do that. The next statement, I need to move some of these things down. Okay. So the next statement says that if we have a series that we know converges and we multiply it by some constant, then the new series also converges. So let's take a look at our AN. We know that the sum from n equals 1 to infinity of 1 over 2n converges. What about this thing times 3? Well, this thing ends up just being 1/2 times 3 plus 1/4 times 3 plus 1/8 times 3, etc. And again, using one of our sort of fundamental how arithmetic works rules, we can factor out a 3, and then this is just 3 times the original series itself. And again, because this inside is a finite number multiplied by 3, it's still a finite number. Okay, so those are those are explanations for why these statements hold. I want to also talk about why Rule 2 works. Changing a finite number in a series does not change whether or not it converges. So again, let's use our example where the sum from n equals 1 to infinity of 1 over 2 to the n. So this thing is, I'm going to write it this way, 1/2 plus 1/4, 1/8 plus 1/16, etc. We've said before that this whole thing ends up equaling 1, and changing a finite number of terms in the series should not change whether or not it converges. Since this series converges, if we change something in here, let's change this from 1/4 to pi, well, we're adding together all these infinitely many things. That's certainly going to change this number. I believe then it becomes 3/4 plus pi. So it converges to a different number, but it still converges. So if I were to then change another number, then yes, if our series converges, it might change what this converges to, but we're not going to change whether or not it converges. The same type of logic applies if it diverges. Changing a single number or changing a finite number of numbers isn't going to impact whether or not it converges or diverges. Cool. Okay, and then there are two more statements that I want you all to work on your own. So hopefully I'm recording this on Tuesday. Hopefully you're watching this before class on Friday. Your in-class on Friday assignment is discuss why these things work. And I want you to come up with some sort of explanation, especially for this part. If the limit as n approaches infinity of this thing, in other words, if the sequence doesn't approach 0, then the series diverges. Okay, so that's the focus. Once you've got that, also discuss why if the limit just doesn't exist, then it diverges, and also discuss this idea that sort of the divergent analog of the second part of statement 1. If we multiply through by a constant, that shouldn't change whether or not it diverges. Okay,